Let's see if we can get a start here. This is the rinse. Uh-oh. Hey, it did it. Started off a little sluggish, but it did it. Now we're on the rinse cycle. The spin cycle was no problem because the motor never stops running. It switches from agitating to pumping out the basin, and then it switches on to the spin cycle all the while with the motor running, and it never actually stops. So it only has to start again after it's, has to refill the basin. So yeah, cool. Now what I'm thinking to do, because an induction motor is a very reactive load, and generators, especially small generators, do not like reactive loads at all. The problem isn't engine horsepower, the problem is the generator's impedance is too high. I'm thinking to determine the correct amount of capacitance to put in parallel with the motor, as I'm shaking this around, such that we improve the power factor at the generator during starting and running for that matter, and simultaneously reduce the actual ampere load on the generator. Two things that'll help keep the voltage up. And induction motors don't like starting under low voltage, as you've seen. So boosting the voltage, I bet it'll just take off just fine. Cool. Well, heck, maybe when this is done, we'll let it run the dryer. There's a bit of irony there. We've got all that heat blowing around outside from the engine that could be drying the clothes, but will burn more fuel in here.